Hello everybody, our team is TMU Y&K. My name is Lianchao Li. I'm a graduate student at Tokyo Metropolitan University. Today, I will give a brief introduction about our work of our team. I will explain it from the following four aspects. The first part is knowledge base, next the rule base, then the results, finally conclusion and the future prospect. At this time, we've made some different things when we built rule base. In this report, we present a robotic prediction for game of Go, which based on fuzzy markup language. The organizers of the competition provided 55 training games data and 15 testing games data. We separately integrated the two parts of the data into Excel document. We choose the data from DBSN to the WTMR as input and the win rate of black as output. Our goal is to make a fuzzy inference of our win rates of black based on input to make it closer to EBWR predicted by Alpha OpenGo Airboat. This is our knowledge base. When designing the knowledge base, we designed the simulation numbers to be divided into 3 equal parts according to the interval of 0 to 20,000. The prediction of rate of dark forest is also divided into 3 equal parts according to 0 to 1. And the top move rate is divided into 2 equal parts according 0 to 1. In order to make the output more accurate, our output result interval is divided into 5 parts from 0 to 1. We choose the winning rate of black as output and all others information as our input. Why do we choose the winning rate of black as output but still use the white information as input? Because we believe that dark forest will make a comprehensive reference to the black and white simulation data before giving a judgment of the winning rate. Here is the way how we built our rule base. Before we built the rule base, we've done some pre-processing of the data, and expert experiments information has been widely used in engineering field. This method proved to be effective. So we combined these two ways to get our final mixed rule base. As mentioned above, we have deleted the rows in which row of the database does not completely capture information of black and white. All the data we use for the next experiment are pre-processed data. Here is the way how we built our calculating rules. According to our knowledge base, we use the formula to generate a total about 324 rows because the mission is to evaluate the winning rate. The winning rate given by the dark forest is the most important basis for analysis. So we give it to the most weight. Correspondingly, we reduce the weight of the number of simulations and the top move rates. Because black and white pieces data are taken into account, so When designing our rows, the black data is positively correlated, and white data is negatively correlated. The expert information we use here refers the analysis of the training data, and the values are evaluated in a similar partitioning method and then abstracted into expert experiments rules. For example, when the number of simulation calculation is 2000 is 20,000, it can respond to the height of the knowledge base. At this time, we give a high evaluation to it. And the corresponding other inputs are also generated according to this method. After analyzing all the data, we first remove the generated and duplicated rows. In the remaining rows, some of the rows that have exactly the same input but different output results appear. In this part, we made a manual judgment and deleted the unreasonable output we thought. Finally, we got about 70 experts' experiments information from the training data. At this time, we use this part of the rows to replace the rows generated by calculation. Then we use genetic algorithm to train our data. After genetic learning, we calculated the mean square error and accuracy of our training data according to the rules of the original design. The matching degrees of the training data according to the designed rule base can reach more than 40% without training. After training, accuracy is further improved. The knowledge base changed a lot at 10,000 generation. The output accuracy of testing data reaches 60% at 10,000 generation. In 1,000 generation, the accuracy reaches 70%, but from 3,000 generation, the accuracy has dropped to about 60%. So, after 1,000 generation, it may have caused overlearning. We have improved our accuracy by introducing expert experiments. So, how to improve the method of rule-based establishment is very important at fuzzy markup language. That's all. Thank you.